Okay, here is problem 13. The diagram shows part of the graph of a curve with the equation y equals e to the 2x cosine x. Show that the derivative is equal to this. Okay, so we're going to have to do the product rule. So I have a function times a function. So u is going to be e to the 2x, e is going to be cosine x. We'll do the easy one first. The derivative of cosine x. I can look this up on my formula packet in case I forget. If I have cosine, the derivative is negative sine. So this one's a negative sine x. This one I have to use the chain rule on because I've got a 2x up there. So e to the 2x times the derivative of 2x, which is 2. So there's that. Now I need to crisscross applesauce. So I'm going to have 2 e to the 2x times cosine x plus this side. Notice this negative. I actually am going to go ahead and take care of that. Put minus. Minus, because a negative times a positive is a negative. So negative e to the 2x times x. So there is my dy. Okay, find the second derivative. So now I need to find the derivative of this. I'm going to copy it down to help me get started. E to the 2x cosine x minus e to the 2x sine x. So I'm going to find the derivative of this and then the derivative of that. So again, I'm going to have to do the product rule. Big mess, huh? So let's see. Actually, do I want to do it? I think I'm going to actually factorize this first and then use the product rule. So I notice that they both have an e to the 2x. So I'm going to bring that out. E to the 2x times 2 cosine x minus sine x, is what's left behind, 2 cosine x minus sine x. So now I'm going to use my product rule this way. U is going to be e to the 2x, so the derivative of that, I know that, so I already did it up here, that's 2 e to the 2x. And then my v is going to be this whole thing, 2 cosine x minus sine x, which I can do in pieces. So the first piece, I keep my 2. The derivative of cosine is negative sine, so negative sine x minus the derivative of sine x is cosine x. Now I can crisscross applesauce. So this one times this one. I'm going to do this one first. Smaller. Times parentheses. Don't forget your parentheses. These are very important. Sine x plus. I'm going to do this one. Again, I'm going to start with my e to 2x times negative 2 sine x minus cosine x. I could clean that up a little bit. So I am going to go ahead and factorize out the e to the 2x. So I'm going to get e to y over dx. For the second derivative, I'm going to bring out my e to the 2x, and then I'm going to distribute this, so I get 4 cosine x, 2 times sine, negative 2 sine x, plus, see, I brought this out, and I distributed this. Over here, I'm going to have negative 2 sine x minus cosine x. Now I notice I have some like terms. So inside the parentheses here, I can put my sines together, and I can put my cosines together. So my final answer, d squared y over dx squared, I can simplify this to e to the 2x times, let's see, 4 minus 1 is 3 cosine x, and negative 2 plus negative 2 is negative 4 sine x. So there is my nice cleaned up answer. Okay, there is an inflection point at P, point P, with x and y are going to be represented by A and B. Use the results from above to prove that the tangent of alpha is equal to 3/4. Okay, this is prove that is like a show that. So I can't start with the answer. I have to start with the stuff from above. So when it says inflection point, that's when the second derivative is equal to 0. So I'm going to say e to the 2x times 3 cosine x minus 4 sine x is equal to 0. And now it's really handy that I factorize this because I can now use my zero product property. I'm going to plug in where the x's are. I'm going to call that A. So I'm going to have, so let's do that right now. Solving for A. And then change this to A's. So e to the 2a equals 0, and 3 cosine A minus 4 sine A is equal to 0. So this one is impossible. You can't raise e some exponent and have it equal to 0. So that one's no solution. Can't do that. This one, however, though, I can move the sign to the other side. What I'm thinking is tangent is the same as sine divided by cosine. Am I off the bottom here? Sorry. So I use my zero product property in case you can see that. I'm using a different teacher's classroom, so I'm not comfortable with where I am right now. All right, so I'm using the idea that I know tangent is the same as sine divided by cosine, and that's in the formula packet in case you don't remember, but that's the thing to remember. Equals to 4 sine A. So I'm trying to get tangent, I need to get sine divided by cosine. So what I'm going to do now, and I'm trying to get 3 over 4, so I'm going to divide both sides by 4. So I now have 3 cosine A over 4 equals sine A. Now I'm going to divide both sides by cosine. So if I divide by cosine, this cosine's going to come over here, and I'm going to be left with 3/4 is equal to sine A over cosine A. Sine divided by cosine is just tangent of A. So there it is. I made it. Okay, the gradient of the curve, prove that the gradient of the curve at P is e to the 2a. Okay, there is an inflection point at AB. Use the results to prove that tangent of A is equal to 3/4. Okay, the gradient of the curve at P is equal to e to the 2a. So I know the A value, or the x value of P. I got that. No, I don't. What do I have right now? Let's see. I know that the tangent is equal to 3/4. What did I do? Let me look at my work here. So I'm going to use the first derivative to talk about gradient. So let me get my first derivative. The first derivative, so the dy dx is equal to e to the 2x times 2 cosine x minus sine x. And I know that that has to be equal to e to the 2a. And when it's equal to e to the 2a, what am I trying to figure out? Oh, I'm trying to prove that. Sorry, I don't know that yet. Oops, I can't see that. So I know that, I know what I can do. Okay, so what I can do is I'm trying to figure out what is this equal at A. So I'm going to plug in my A's. So e to the 2a times 2 cosine A minus sine A. And I'm trying to simplify it down to this. So what else do I know? I know this. I know that I can substitute in for sine A. I'm going to use this right here. I'm going to substitute in for sine A. I'm going to substitute in 3 cosine A over 4. So I'm going to take this and I'm going to substitute in this. So I get e to the 2a times 2 cosine A minus 3 cosine A over 4. So what I'm trying to do is I'm trying to make this disappear. Let's see what this is equal to. So if I do this, I have e to the 2a times 2 cosine A minus 3/4 cosine A. And now I can simplify this. 2 minus 3/4. 2 is the same as 8/4. Okay, so I can write the 2 as 8/4. That's 8/4. 8/4 minus 3/4 is 5/4. So I get e to the 2a times 5/4 cosine A. And what is, let's see, cosine of A, okay, for some reason, okay, how did I figure this out? Oh, I know what I did. Okay, so if tangent, this is crazy, how did I figure this out? If I know that tangent is 3 over 4, here's my theta, or my angle A, sorry, angle A is 3 over 4, then what does the hypotenuse have to be? The hypotenuse has to be 5, so therefore I can solve for cosine of A. Cosine of A is going to be 4 over 5. So this right here, by using Pythagorean theorem, I can figure out what A is. Since I know what tangent is, I know two sides of my triangle, I can figure out the third side. So I know cosine of A is going to be 4 over 5. So I have e to the 2a times 5/4 times 4 over 5. Cosine of A, my A is going to be 4 over 5. And then those cancel out, those just equals 1. So I'm left with e to the 2a. Okay, that was brutally hard. I had to pause and think a long time. So that's number 13. Ooh.